Hello, my name is Mesut Durukal. I'm a software test engineer. In software testing, I have about 15 years experience and I have done lots of different things in lots of different ways. Sometimes manual testing, sometimes automated testing, sometimes functional testing, sometimes other types of testing in different levels, integration or system or acceptance levels, and in different places, sometimes in the customer sites, sometimes alpha testing, beta testing, lots of different verification and validation activities I have done and I have been involved in several projects in different domains. But whatever we are doing or in what ways we are doing this efficiently is very important, because otherwise we are trying to cover a very comprehensive scope, and the systems that we are testing nowadays is not very easy and straightforward to test, because they have complex and complicated structures, architectures, different interfaces, and they are interacting with different applications as well. So we have to cover lots of different interfaces and lots of different functionalities, specifications. So doing testing efficiently is very important. In this regards, the implementation of the test cases and the executions of the test cases is very important, and doing them efficiently will directly affect our success criteria or success objectives, because otherwise we may be fall behind of our schedule or the key results or the key objectives. So doing this very efficiently is an important aspect. So in these terms, I realize sometimes there is some issues or problems which is affecting the efficiency. For example, in most of the organizations I'm working in, I realized that some problems were being trying to be solved again and again in different teams. For example, when I'm working in a project, I realize we are struggling to find a solution against a problem, and whenever I switch to another project or go to another team, I realize that they are trying to solve the same problem in different ways. So this is a duplication problem. So the same problem is trying to be solved again in different places in different ways. So if someone cooks the food for us, if someone builds or develops a solution for us to be served, if they serve us a solution from a central approach, then it would be much more consistent and maybe removing the duplication. So today we will talk about testing as a service. We will develop the solutions to the most common problems from a central framework approach, and then provide this solution to multiple teams. So we will talk about removing duplication or improving the reusability. So we will try to build some reusable central approaches, central solutions against the most commonly faced encountered problems, and we will provide to people. So what we will go through is, first of all, I will make an introduction about a little bit going more detail in the problem statement and the importance of duplication, and or in the other way, in the other words, reusability, the importance of this in testing, and what kind of preparations or analysis the feasibility studies we can do before starting our implementing these reusable classes or functions. And then in the second part, after this preparation part and the problem statement, we will talk about how we can implement these kind of functionalities. And in the last part, after even implementing, we are still not done. We should do continuously doing the maintenance, and we should support the teams or the people that we provide these solutions in different ways. So we will discuss about serving, still continue to serve people and support them in different ways, like the trainings or the documentation or even the maintenance and monitoring activities. So I will share lots of different monitoring dashboards and visuals to interpret, better understand what the numbers are saying to us, like a little bit more mining data from mining information from raw data, we could say. So let's get started with the first part, which is the introduction part, which mainly we will talk about the problem statement and then some basic preparations before we just start our implementation. So we are talking about duplication, right? Because sometimes we can see that some different teams or organizations in our whole company or how our whole project, they are developing some different solutions against the same problem. So we can say that they are following different approaches. there is not a standard. So every team or every sub project is following a different approach. So this is the first thing. And then we can say that, as we briefly discussed in the previous slide, sometimes they are struggling to find the solutions which were already solved in the other teams. They are wasting time to find a solution which were already discovered in the other teams or the other organizations. And this will reduce this will raise some duplication as well. For example, we can see some different algorithms or implementation ways. So what does it mean? It means some code duplication and the duplication of the efforts as well. So they will try to solve the same tasks again in different boards, or even if they solve easily, quickly, maybe if they follow different implementation ways, we will see lots of different code blocks implemented in different ways. Some of them might have some anti-patterns. Maybe some of them are not designed in the best patterns. So maybe they will have some reliability issues. So we will see the potential risks of this duplication and ways to cope with reducing the duplication and improving the reusability in the later slides. But first of all, let me a little bit illustrate this scenario to better understand what I'm talking about. For example, let's think about a very simple test scenario, which is basically finding a button and then checking an attribute of this button, which is the visibility. So it should be visible. We should assert that the button is visible. And then we should click the button. And after we click, we should assert that a label shows up, which is containing a string or a text value that we want to see on the label on the web page. So this is a very simple test scenario containing just a few test steps. Just locating the element, finding the button, the component on the page, and then doing the visibility assertion, click step, the interaction with the button, and then one more assertion, just verifying that the label is there that we want to see, which is the expected result for us. So this very simple test scenario, it's not even a whole end-to-end scenario, but we can say it is a test step which can be a part of the whole scenario. Finding the button and clicking. So this can be implemented in 4 different ways. I'm sure this is not the all implementation ways. I'm sure there can be lots of different ways as well, but at least 4 different ways we can see on this slide. So this implementation is provided from the Cypress E2E test automation framework, but even if we are using different tools or libraries, there can be lots of multiple ways to implement the very simple, very short scenarios or the test steps. So again, what we can realize is maybe some of them is not implemented in the best way. So there will be some reliability or the code quality aspects as well. So how can we avoid this kind of risks or the potential issues, and even at least duplicating the same scenario? How can we avoid? So what if they do not try to implement this scenario from scratch? But if they are already provided a solution, that solution was already cooked in our kitchen, in our testing kitchen, and if they are provided to them, then they can just call these functions from the framework that we provide to them. So what we are proposing here is, instead of implementing the scenarios from scratch, just call the functions from the framework, central frameworks, which is developed by following the best coding practices and the patterns, by avoiding some anti-patterns. So in this way, we will already be avoiding the risks or the reliable code quality issues, and we will be already providing those different people to easily call the functions rather than duplicating the implementation efforts. So what we are targeting here, what are the aims or what are the objectives? First of all, we will be developing a standard. So we already know which kind of patterns or approaches are followed in the central framework. So we can just maintain that standard. And even if we want to change something in the framework, then we only have one reference point. So instead of going to a lot of repositories, we already know where the implementation is done. We just can go to the reference library, the dependent library, and we can update our code or improve the quality in the functions or the classes that we implement. So in this way, we will be avoiding anti-patterns and duplication, and we will be providing solutions to the common problems. And not only the functionality or the solutions to the problems, but we can serve some other side functions or other features as well. For example, when we provide these features, the people can already use some extra reporting functions, or maybe some other accessibility or other non-functional aspects as well. So in this way, not only with the functional aspects, but lots of different aspects we can already provide in the scope of this whole solution. It sounds good. It looks pretty insightful and promising. But how can we proceed on this long way? Because we need a roadmap. Otherwise, we can be lost during this long implementation. So first of all, we have to decide about the objectives or the key results. Because after some time, we have to be sure that we are really going in the correct way. This solution is really helping people, facilitating the processes. This is our goal. But how can we be sure about that? So we need some metrics. We have to measure how much progress we are doing in terms of our goals. And then we can collect some different struggles to define, to figure out what kind of common problems people are having. And then we can create a requirement list on top of those common problems, and we can do the prioritization to understand which one is mostly the high criticality level, and which one is mostly needed in an urgent way. So in this way, we can start our tasks starting from the highest priority tasks or the needs, which will be provided to different teams. So since we just talked about objectives and metrics, and I know that sometimes measuring quality is not easy. It is super difficult because whatever we try to measure, for example, let's talk about the number of bugs we have. Is it a good metric? Maybe yes, maybe not, because if we concentrate on the number, concrete number itself, then maybe it not might be that much meaningful, because I have, let's say, 100 bucks. So what? What does it mean? Because there's high criticality bugs or high priority bugs, and there's low severity bugs as well. Or there's lots of different bugs coming from different stages. There are some of them found in the early stages, which is already we want to do, or at least ideally we want to avoid the bugs rather than finding them. But some of them are found in the production stages. They are escaped bugs. So rather than only measuring the number of bugs, we can do a more detailed analysis. And of course, the number itself will never give any insights or any concrete results. It may give some insights or ideas, but it will not give the final decision to us or a final result. Or similarly, like the number of test cases, for example. I have 1000 test cases. So what? What does it mean? It might not be that much meaningful. But what we can do is, basically, roughly, we can collect all these metrics under two fundamental pillars. As quality assurance teams, what are we trying to do? We are trying to confidence in our team to provide the best product to our customers. Because we are trying to verify our functionalities, but we have to do the validation as well, because verification is not the only thing that we can do in the scope of quality assurance, but validation is another fundamental. So we should assure that we are providing the correct product and which is functioning very well, properly to our customers. So in these terms, what we can do is maybe we can perform a measurement on our coverage. How much functionality or the specification are covered by our test cases. But still, this is not enough, because even if we have 100% coverage, how capable our test cases are in terms of catching the bugs. So not only the quantity, but also the quality of the test cases also matters. So what we can do is we can concentrate on the escape bugs which are not found by the test cases. So in these terms, we can understand how capable our test cases are to catch the bugs. And if we are having lots of different escape bugs from a specific dimension, we can try to improve our test cases in that manner. So we can try to improve the quality. This is all about the quality and the confidence. On the other hand, there is the delivery speed as well. So if we are trying to, of course, we will try to maintain the highest quality, but if we are too slow to provide our deliveries, we will be very maybe late in the market, because there's a great rivalry in the software market. And if we provide our solutions too slow and too late, then maybe customers will give up using our products and they will try to find some different alternatives. So speed is very important, and what we can measure in these terms is maybe the automation coverage is one thing that we can check it out, because most of the time testing manually is slower than testing in automated ways. So we can check the automation coverage, but also not only the coverage, but also the execution duration. So it can be automated, but still it can be fast. So we can measure our execution durations and the reliability ratios as well. For example, even if they are running very fast, they can be failing from time to time. They can be flaky. So we can measure the reliability and ratio of the false alarms. So in these terms, if we have lots of different false alarms, we can try to reduce the ratio of the flaky test or the flakiness. And of course, not only finding them, but also the maintainability of our test code, how easily we can fix them. So the test fix time also we can measure to get an understanding about the quality and the support of our quality assurance activities to the delivery pipelines and the lifecycle. And after selecting the objectives and the key results, what we can figure out is we can talk to lots of different people to understand what kind of challenges they have. So in this study, in this project, we created an initiative to talk to lots of different projects to understand what problems are the most commonly encountered by different people. So sometimes they were complaining about executing on different browsers, so the compatibility issues. Sometimes they were complaining about parsing the responses. It was not straightforward and it required some implementation effort. And sometimes they complained about the historical test data. They had to prepare some dashboards, because whenever they use trivial reporting algorithms or libraries, they will only have the individual test results but not the historical and architectural test results dashboard. So they cannot do a comprehensive analysis on the executions. So we collected lots of different challenges from different dimensions. Some of them are directly related to the test automation. Some of them are related to monitoring activities or reliability issues. So we can say that we collected the requirements pool. And then we derived the specifications that we need on top of those needs or the necessities in the test automation framework. So we figured out that maybe we need some components like front-end module, back-end module, and reporting module. Those can be regarded or considered as plugins of our test automation framework, which will be a central solution that we will provide to other people or other teams. And then on each module, we listed lots of different requirements that we want to implement. So this will be a roadmap for us, and on top of these requirements, after doing a prioritization, we will start implementing one by one, starting from the highest priority. After the preparations are done, we can continue with our implementation. But first of all, of course, we have to prepare a good architecture and start our implementation in a good way, in a good direction. Otherwise, if we start in a wrong direction, it might be a little bit too late after some time to correct the mistakes that we have already done. So I want to start with an architecture and basic depiction of how the structure of the test automation environment looks like. So we want to this framework or central approach to be used by lots of different repositories or different applications. So whenever we provide these solutions, they can use it, this framework, to test or to verify lots of different applications. So at first, what we can say is we need some workflows or some other GitHub actions or jobs which can be called by lots of different repositories. So instead of duplicating the code repository to maintain the test code, we can just keep one repository which can be just downloaded into several different projects, and they can just call the workflows which are already reusable. And then after our workflows are triggered, which can be called either by some timely based scheduled jobs, or maybe after every commit, after every push, they can be triggered. After the workflow is called, the tests are executed. So the test runner is called by the workflow. And then what the test runner is doing is, first of all, it is including all the test spec files into the execution scope. I mean, not necessarily all the implemented test spec files, but only the desired ones. For example, sometimes we may want to include only a subset of the whole test cases into execution, because we might not want to include all the test levels, but maybe only the smoke or the sanity test cases. Or maybe sometimes we need to do the regression testing, so we might want to pick only the relevant test cases, which is related to the recently implemented functionality or the feature. So the test runner first selects the test spec files to be included in the execution scope. And then after doing this, the first execution blocks are the text fixtures, which are the running before the suites or before each test case. So before all and before each methods or functions are running whenever the suite execution is started. So this is already a good way to remove duplication, because if we have some repeated steps inside the test spec files, we don't have to duplicate each of them in each test spec, but we can just move to the before all or before each blocks to be executed before starting every individual test case. And after doing this, already the configuration provided by the user can be read, and some classes or the instances can already be prepared. For example, if we provide some different execution environments or the platforms, then the relevant locators can be set up and all the instances can be prepared, ready for execution. And after this, of course, the execution is started and the test cases are executed either in parallel or in just one monolith approach. It depends on our configuration, but most of the time, of course, doing a parallel execution is reducing the total execution duration. So in this way, we don't have to wait all test spec files to be executed one by one, but we can just let them run in several virtual machines in the meantime, so they can parallelly execute. So of course they can execute on the platform that we wanna initiate, so we can select on which browser we wanna execute these test cases. So the relevant drivers and the browser instances are initiated and the test steps are performed one by one. And eventually the execution is completed. So what we will do next is, of course, we will collect all the execution details and the execution artifacts, and we will publish them to our dashboards for the monitoring purposes. Because whenever the execution is done, if we do not report the results, then we will not be sure which test case is passing or which is failing, or even some other details. For example, whenever a test case fails, we want to see the screenshots, right? Because in that way we can better understand what happened during the failure, what was the status of the web page. So taking a snapshot or screenshot and attaching all the evidences along with these logs and screenshots would help us a lot to make a troubleshooting. So in these terms, the reporting to dashboard would be the last steps. So this is the overall architecture of a test automation environment and how it works one by one, starting from calling the job from either timely based scheduled jobs, or whenever we push a new commit or change to our repositories, the test case executions are triggered and we can eventually see the execution details and results in our dashboards. So to implement this architecture, we can use lots of different technical stacks like the libraries, frameworks, tools. We can all decide from a very broad range of tools and options. There are lots of different alternatives. So how can we decide which one is best for us? Of course, we can do a comprehensive benchmarking, and we can decide to the best tools or the libraries, the frameworks that we can utilize in our test automation environment by checking some decision criteria. There are lots of decision criterion. For example, the execution speed is one of them, or the ease of coding. Whenever we select a framework, can we easily use it? Is it really user friendly, or is it really understandable? The ease of reading, not only the ease of coding, but ease of reading or understanding the code is also important. So all these kind of decision criterion can be a base for our checklist to do our benchmarking, and then we can decide the best tool. So in our project, I did a very similar study. I selected one test scenario which was already implemented with my current solution, and then I tried to implement this with all the alternatives that I can choose. For example, I implemented this with Cypress, and then I implemented with Playwright, Nightwatch, Selenium, Test Cafe. Every one of them I had an experience. And I already had an opinion as a developer experience. And then I, of course, measured the execution durations. I collected the results regarding the execution duration or the execution speed, both in the local machines and the CI machines, remote machines as well, because sometimes they are different. Because sometimes they have different dependencies. Even downloading the resources on the remote machines can take different durations or the time ranges. So I, after collecting all the results, I decided the best option to go. And then, of course, after deciding the architecture and the technical stack, I have to keep in mind some quality aspects. Let's a little bit talk about what kind of quality dimensions we should keep in mind before our implementation starts and before we implement our solutions. Because if we keep these quality aspects, then we will be getting rid of the technical debt. Because if we just start implementing without taking care of paying attention to these quality aspects, after some time we will have lots of different technical debts. There will be some quality issues. So let's a little bit discuss about different quality dimensions. So the first group I want to share is starting with the flexibility. The tools or the frameworks or even the solutions that we are implementing should be flexible enough to do different configuration. Whenever we try to change our configuration or environmental variables, we should be easily doing that. And we should, of course, think about the integrity. Sometimes we will execute in different platforms. Sometimes we will integrate to Jenkins, or sometimes we will switch to the project. So they will be using GitHub Runner, for example, GitLab Runner, sorry, or GitHub Actions instead of Jenkins. So we should think about integrity as well. And scalability and portability is one other aspect in which we can consider about doing parallel runs and executing in different platforms, not only the desktop platform, but also the mobile devices as well. What happens when we change the test execution environment? And of course, the solutions that we are providing should be goal-oriented. They should be really solving the most common problems. The highest priority struggles should be solved with this central approach. Because if I'm trying to cover the trivial, not really high priority tasks, then maybe people will still be waiting for solutions to the problems that they are waiting to cope with in an urgency. So this central approach would not be the thing that they need in that case. So concentrating on the high priority tasks would be also an important aspect that I should keep in mind. Moving on, there are lots of different quality aspects. For example, understandability. When I provide this solution, people will be easily using this. People will understand how to use it. And of course, it should be transparent and visible. It means what performance or what kind of steps are performed should be very visible. We should do all the loggings, and we should report all the evidences and the execution artifacts to the dashboards and the platforms that we are using for monitoring purposes. And of course, documentation is a great way to support people to improve the understandability and the user friendliness, usability. And of course, whenever we have some issues, the troubleshooting, the maintainability, it is possible to potentially likely to have some issues, but even if we have them, how easily we can fix them. So troubleshooting and applying the fixes is one more thing that we can consider while doing our implementation. There are some more artifacts that we can think about. For example, the reliability, how reliable the tests are. For example, when a test is passing, am I sure that it it really ensures all the aspects of the quality. So sometimes the test passes because I don't have enough assertions, or I'm not doing the proper verification or the validation steps. So I should think about all the coverage aspects and the proper assertions implemented in the test automation framework. And it is really directly related to the coverage. And while I'm doing some executions, I should not raise too much load in the test execution environments. I should clean all the objects or the other instances I already create during the execution. So my test cases or the test solutions should not be disruptive. So I should implement some solutions which are already cleaning all the unneeded objects or the instances created during the executions. And testability is one more thing. Sometimes we are not having the chance to test some specific corner cases. So in these terms, we might not have the testability. So what we can do is, if we don't have access to reach or to call the some certain interfaces or the other subsystems of the other subsystems, then what we can do is we can just mock responses coming from those different subsystems, because normally that is not under our control. So maybe we don't even have them. So it is not ready, that other subsystem that we are communicating with, but we want to test our subsystem which is under test. So what we can do is we can just mock the responses coming from the other subsystems. So we can implement this kind of mock solutions. And finally, the last set I want to share is starting with the performance. Of course, even if they are functioning very well or the usability is very well, there's one more thing that we can consider, which is the resource consumption and the performance, which are really very relevant to each other. So if the tests are running very slowly or they are consuming too much resources, then it would not be an efficient way. So the other people might hesitate to use our solutions if they are not performing well or consuming too much resources. So we can consider about this, and we can think about doing multiple executions in the same time. This is another way to do the parallelization. And of course, finally, we can do a proper versioning. So we can decide a roadmap, and in which version we want to update what kind of features or functionalities, and with a proper change log and a documentation, we can manage our versions and the feature updates as well. So after implementing all these, of course, we should continue to support people. So first of all, we should understand if this is really facilitating the processes that the other people are following. So we can already have an understanding if our aim or the objective is already met or not. So let me a little bit give an idea about how it changes people's lives. Is it really making life easier for every one of us? Let's a little bit talk about this. So what I have done to understand this is, first of all, I measured the implementation effort without using the central approach, and then with using this central approach. So what I have done is, first of all, I listed what kind of task I am doing whenever I'm implementing a test cases from scratch. First of all, I have to define or figure out all the locators which are used to find the elements on the web pages. So sometimes it was challenging. It was not that much straightforward. Sometimes we can just inspect and the ID or the class path or the X path or the class name is already there. But sometimes it is not that much straightforward. Sometimes there are some hidden elements, drop down menu items, or there are lots of different things that on which I really spent some time to find the locator. And then even implementing test steps, there are lots of different ways to do the same operation. Sometimes I can follow one of them, sometimes I can follow the other one. So figuring out which one is the best was another challenging task for me. So there's lots of different ways, as we discussed in the previous slides, which can be done to perform a test step or a test action. So figuring out and comparing all these solutions was something else which was really time consuming and requires some effort and maintenance and analysis tasks to be performed properly. So after doing this analysis, I realized that it was really very straightforward to use the functions that was provided by the common framework. For example, on the left hand side, we can see that uh, we can see the test implementation that I have done from scratch. On the right hand side, we can see I'm just calling the function provided from the framework. I just read the documentation. I just understand how I can call the method which is already doing all the steps that I'm trying to implement on the left hand side. So just calling the function, relevant function, with the correct arguments, which can be done with only one line, is equivalent to all the implementation done on the left hand side. So it was pretty straightforward. So measuring the metrics, I tagged some tasks on Jira, which was the issue tracking system in my project, as test automation. I put some labels, and then I pulled all these tasks tagged with test automation, and I checked the timestamps. We have some different status on these tasks. So whenever we create them, normally they are in new status, and then when it is assigned, they are going into assigned. And whenever I start working on them, it is going into in progress. And when I complete, it is continuing with the next stages, like maybe ready for review, and eventually it will be closed after fixed. But what I'm interested in this case is in progress status. How much time do I spend to complete or to perform this implementation, this test automation task? So what I measured is I was spending in average 2 hours to prepare all the page object model and all the locators. Around 2 hours, I was able to finish this task. And then to implement the test steps, I was spending around 3 hours in average for the test automation tasks. So we can say in total, I was spending around 5 hours. But after I utilized the test automation framework, with the test automation service which was provided to me, then I was spending in average 30 minutes to implement the same scenarios. So we can already see that it is a huge advantage, it's a huge benefit, and we can already do a much more efficient implementation way. And after that, of course, we provided some monitoring and reporting libraries in the scope of this testing as a service. And after people use that, the execution details would be already reported into monitoring dashboards and the charts and graphs we already prepared. Because this is important, the making use of the visuals, because numbers are great. But sometimes it is not easy to interpret what this data is telling to us. Grabbing some information from this raw data is not easy. But if we transform all these numbers into visuals, it is much more easier to understand what's going on in our environments. For example, if we utilize some line charts, we can easily see the trends. Or if we use bar charts or pie charts, we can use lots of different distributions. So I will share just a few examples about monitoring charts that we prepared. So we collected lots of different metrics to have an idea about the quality of our products and quality of our development principles and the development life cycles, the approaches that we follow as well. So in these terms, whenever we realize there are some improvement rooms in the development approaches that we follow, then we were concentrating to apply some improvements, and then we were continuously doing the monitoring to understand if the fixes contributed to our solutions or not, if whether they didn't change the progress at all or not. And of course, we provide some trainings in lots of different ways. Sometimes we had some recorded videos, onboarding videos. Sometimes we had just some documentation, and sometimes we had some in-person meetings and demonstrations to provide some trainings. And in this way, we supported this testing as a service to people to better use it and to improve the usability and the user friendliness of the solutions that we are providing to them. So wrapping up all the discussions that we have made, testing as a service is aiming to solve a problem which is based on the duplication and the maintenance and the analysis efforts, and basically trying to improve the efficiency. If we provide just a central solution which is already avoiding the anti-patterns, which is already following the best practices, then people can just use them. They don't have to care about anymore about providing or finding solutions to the problems. Again, with some other ways, they will be already provided with the best solutions. So how we can proceed on this project is we can collect lots of different struggles or problems, the challenges that the people are facing, and we can do a prioritization. Then we can prepare our architecture, and we can decide the best tools and libraries we can utilize in this test environment. And finally, we can publish our solutions to cloud platforms, and then people can just download these dependencies and import these solutions into their own projects without duplicating the test repository. They can just call functions and the specifications implemented in the central framework. And of course, after providing the solutions, we continue to support people by providing trainings and documentations, and of course doing the continuous maintenance. Whenever they raise some bugs, we should solve them as soon as possible, and we should improve the code quality in the test automation frameworks that we are providing to them. So thanks a lot for listening to me. I hope this will give you a lot of insights about how to implement the testing as a service and providing to different people. In this way, I believe this will improve the contribution of your personal achievements as well. And personally, you can improve your level of impact when you provide testing as a service to whole your organization. Your impact range will not be only on your scope, but it will be a broader range, and you will provide some good quality practices to lots of different people.